Word. So as I promised you, today gonna be also a very small subject, which is sequence detector. We talked about it, but we haven't covered it in like in details and depth, right? So sequence detector or pattern detector. Okay. In the sequence detector, basically, you already have a device that's a detector. Definitely, it's actually powered up with a clock. That means it's a sequential. And you have a certain pattern you are looking for in a stream. So that means there's an X and there's a Y. Sounds good? Example for this, I told you, right? Human DNA. I mentioned that before too. DNA. DNA, it's basically a bunch of what carbo bases. That's SA, T, C, G. Those are the four carb bases. And the human genomes is basically a bunch of this. It's like A T C C G A C T, something like that. That can be a gene. That's example. Okay, gene for the color of the eye, color of your eye, for instance. It's this gene is controlling it. Okay, how I'm gonna use it? How I'm going to, you guys can hear me or you cannot hear me?
Yeah.
Yes. Okay, so everybody's following what I'm saying, right? So okay, if you want to do this in our binary system, how it gonna work? So one case you can say that's A T C G like this. Those are the four bases. So they're gonna be here 0 0. They're gonna be 0 1. That can be 1 0. That can be 1 1. Right? So if you want to convert this to our binary, gonna be what? 0 0 0 0 0 1 1 0 1 0 1 0 0 1, and that will be my stream going here. And then the pattern can be the gene which is changing the color of the eye, whatever here. So if I find it, I will just what reply and say that I found. Other example that you are looking into signals have been sent through the satellite, and you would like to detect whether the signals broadcasted by CNN or not. Then you already have the CNN pattern. You will run the streaming, and then you will search for CNN in it. If you find CNN, that means it's a CNN. So it's used for communication also. Protocols using sequence detector. Okay, so far so good.
Yep.
Now, how we can build a sequence detector? It's a finite state machine, so it's basically a piece of cake. So using finite state machine will help us to build a sequence detector, and that sequence detector have two different what passes, right? One is called with overlapping, another one without overlapping. What does it mean? So we need an example. So the example is the following. Imagine that I have a pattern, and this pattern from 1 1 1, 3 1s, and I'm looking into this 1 1 1 in a big stream of data, which is like bunch of one and zeros. And like this is a stream 0 0 1 0 1 1 1 1 1 1 1 0 1 1 1 like this. This is a stream. So if I say without overlapping, I should have the following strategy. So the strategy is the following, if I start searching here, right, I found here 0, right? Is 0 belong to those 111?
No.
Exactly. So now, I'm still cannot find anything from that 0. Then up to here I found 1. So that means at least I found something similar there, right? You guys agree? So that's
Yes.
a possible state. Then, I return it back to 0. It's not belong. Here, it's 2 possibilities. So basically, I can actually come out with multiple states covering this. So I have a 3 inputs, 3 patterns input. And I can say that, if I found just 1, then that's actually called state S1. But if I found 2 of the ones, then this is gonna be my S2. Then, if I find 1, 1, 1, then yes, this is basically the pattern, right? And also, I can set up an initial state called S0, which is the state I start from. So if anybody give you, for instance, n-bit pattern, you will end up having how many states? N plus 1. This is one way. There is other ways, but I'm just talking about one way now, okay? So carrying on with this example, so I have here S0, I have here S1, I have here S2, I have here S3. Do you guys agree?
Yep.
Now I can use whatever way I would like to use. Either that I can use melee or I can use more. Make sense?
Yep.
If I would like to use more, what should I do? Easy, busy, lemon squeezy. So now I know that when the pattern arrived, this is the state. It should be the output is 1, right? Because yes, I found the whole entire pattern. I found the whole entire pattern 3, right? Then anything else is gonna be 0. That makes sense? This is what more finite state machine. Sounds good? Now I'm in S0, right? So I'm standing here. There is a possibility that I will find 0. Then I will stick here when the input is equal 0. The only way for me to go to the stick, which is that I found one pattern that the input has to be equal what? 1. Do you guys agree?
Yeah.
Now I'm in S1. If the next for me is 1, then I will go here. But if the next for me is 0, I will return it back to who?
State 0.
S1.
Then here in S2, if it's the next is 1, that means yes, I found the third one, right? But if I found a 0, it will be what?
Back to state 0.
Make sense? Now the trick of the lapping or without lapping. So what is this? So imagine that part of the streaming was like this: 1, 2, 3, 4, 5, 6, 0, 1, 2, 3, like this, right? So if it's not lapping, so that means I found the first one, I found the second one, I found the third one. Now my output is 1. Do you guys agree? Then I return it back from scratch. I'm looking for the first one, the second one, and then the third one will be 1. Then I found 0, it's 0. Then I start 1, 2, 3, and up 1, and you move forward. So that's gonna be Y, the output. That's called without what? Overlapping. Sounds good?
Yep.
Of course, this should go like this, right? That means the next is 0, so I have to start from scratch, right?
Yep.
How about if S3 is 1?
What?
How about if F3 you get a 1? Oh, yes, never mind.
Make sense? Anyway, now if it's overlapped, what does it mean overlap? Overlap is the following. Look, 1, 2, 3, 4, 5, 6, right? So in the overlap, you're not losing the previous knowledge. What does it mean? I have here 1, 2, 3. So that means my output here is gonna be what? 1.
1.
Look at this. But I have 2 here. So this one is the third. So that means the output here is gonna be 1. So what happened? I overlap 2 from the previous to contribute in the next. That makes sense? So
Yeah.
I didn't count from scratch again. That's called overlapping. So in that case, if this is overlap, it's gonna be like this, right? Do you agree?
Yes.
This with overlapping. Let's make this melee. So melee is 0, S1, S2, S3, right? So if I'm 0, the output is 0, right? But if I'm the first one, I'm going by 1, still the output is 0 because I didn't find the whole entire pattern, right?
Yep.
Then if it's 0, I would go back like this to be 0, 0. But then if I go and I found the second one, it's going to be also 1 and 0 because I didn't find the 3, right? Then here, if it's 0, I will go back like this, 0, 0. If it's 1, it's going to be what? 1, 1. Right? Does it make sense to everybody here?
Yes.
Now, if you continue, if it's 0, I'm gonna go back. But if it's 1 and overlapping, boom, 1, 1. What is the next for us to design? Is to make what? A state
Stable.
table, and then you will use this excitation stuff, and you build the JK or the T or whatever flip flop you can use up to what implementation, as you already have done with the finite state machine. I don't need to repeat it because you guys know. So any question regarding the sequence detector? You have any
No.
question?
No.
Hello, the rest of you guys, do you have any question?
Pretty clear.
So is it clear to everybody? If it's not clear, I can repeat. Andrew, is it clear?
Yeah.
Okay. Gabriel, is it clear? Diamond's clear. So if it's clear, write clear in the chat. That's it. Not that many people said clear. Yes. Okay, in that case, I can say we finished. Okay, so we finished the lecture for today. We are done with the sequence detector. We finished the registers. We finished the shifting and notations. And we finished, and even I showed you how to build the memory, right? And also I showed you how to make what, do you remember the processor thing that I showed you, right?
Yes.
Yes.
So I would say there is no lecture on Monday, okay? Because on Monday, I will have a deadline with NASA, so I have some stuff to do. Plus, I will let you guys just focus and study. Then in the coming Wednesday will be the last day before the final, right?
Yes.
Okay, in that case, we can I can show you introduction about how the Verilog work, and then we can see if you have any question or something. I can cover it, and that will be the closing remarks
good.
for the semester. Yes.
Sounds great.
Is it good for everybody? Is this plan make it's reasonable to everybody? Okay,
Yep, sounds
so
great.
I'll see you on Wednesday and no lecture on this coming Monday. Have a great weekend and have a great rest of the day, and God bless all of you. Thank you. Bye-bye.
Thank
Have a
you,
nice one,
Professor.
Professor.
Hey, Professor, are you doing any lectures online? Sorry, on campus next semester?
I don't know.
Or is
It's
it
the
still
last
going to be
question.
online?
I think I will be online.
Okay.
I don't know. Some of the people will do it. When is the final again? You need to search for the final, right? You know how to do it, right, Alejandro? So it should be when. Let me see. We can double check together. There is no issues. We are CBP final schedule spring 2021, right? Here is the link for the website. We are taking this course Monday, Wednesday, right?
Yep.
Then we are taking this course at what? At 12.
1 o'clock.
1 o'clock.
1 second. 1 o'clock, right? So I'm looking for my where's lectures Monday, Wednesday? They don't say.
I can tell, dude.
Huh?
That's gonna be us, Gabe.
What? What?
What?
Hello?
Oh, I'm unmuted. Rip.
So it's Monday, Wednesday, Monday. Where's Monday, Wednesday? This one, right? So Monday, Wednesday. Okay. And we are at 1 o'clock, right? This one, right? So gonna be Monday. Not the Monday of the final. This Monday, the coming Monday.
So not
Alejandro?
it's not next Monday, but the Monday after that, correct?
The exam will be the Monday after, right?
Sounds good.
That makes sense to you guys?
Yes.
So if Monday, coming Monday is what? Coming Monday, 10th, right? So your exam on 17th, right? Your exam Monday 17th, and we're gonna do the same thing from 8 o'clock to midnight with GitHub. Okay, sorry, with Grid Scope. Okay, look.
Wait, Professor, how's your project going for that deadline?
Which one?
The one that's coming up Monday.
Oh, it's a big mess. I finished some stuff.
Do you get like extensions, or do you just have to like do you have to present, or how does it work?
No, it's a grant.
Oh.
It's a grant for $300,000.
Good luck, Professor.
Yeah, I finished.
Yeah,
right.
good luck.
Thank you. So I finished right. It's $300,000 for 2 years, so I can hire students working on this for Venus mission. So we're gonna build the flight control system for the Venus mission. Okay, Luke. So I will keep you guys in the loop. If I get the grant, then I will start hiring. So of course, I will be looking for people. Okay.
Sounds great, Professor.
Thank
All
you guys.
good
God bless
energy
you. Thank you.
away.
Bye bye.
I hope you get the grant.
Oh yes, thank you. Pray for me. Thank you. Bye bye.
Professor?